Part 1 of Unit 3 is a review of the mole. Masses for elements on the periodic table, they are averaged atomic masses. It's a weighted average of every isotope of that element based on its abundance. The mass of individual atoms, molecules, and formula units is reported in AMU, which stands for atomic mass units. So you see that hydrogen has a mass of 1 atomic mass unit. Oxygen, it's 15.999, but we call it 16 atomic mass units. Those numbers are all weighted averages based on the abundance of the different isotopes of that element. And remember the difference between molecules and formula units. A molecule is what we call a single unit of a molecular compound, like water or carbon dioxide. It's only got nonmetals in it. A formula unit is what we call a single unit of an ionic compound, like sodium chloride or calcium carbonate. It's just a nitpicky difference. It means the exact same thing, but we just have to call them different things because they're different types of substances. The technical definition of Avogadro's number, it's that 1 mole, which we abbreviate MOL because mole is such a long word already, is the number equal to the number of carbon atoms in exactly 12 grams of pure carbon-12. So they're saying that in exactly 12 grams of pure carbon-12, there are going to be 6.022 times 10 to the 23rd carbon-12 atoms. Anytime we've got 6.022 times 10 to the 23rd of anything, that's calling it 1 mole. Same as whenever we've got 12 of anything, we can say we have 1 dozen. Anytime we've got 6.022 times 10 to the 23rd of anything, we've got 1 mole of something. We can do some simple calculations to convert between moles and number of atoms. In this first example, we've got 2.5 moles of calcium. We want to figure out how many atoms that is. We're going to start with the number they gave us, 2.5 moles of calcium. And what we need to do is some dimensional analysis. We want to cancel out the units of moles and get to the units of atoms. Remember, in dimensional analysis, the units you want to cancel out, they're going to go on the bottom of a conversion factor, and the units you want to get to go on top. Now that we've got the units in the right place, we have to put some numbers in this conversion factor. We know that 1 mole is equal to 6.022 times 10 to the 23rd atoms. When we do this, we're going to be dividing by moles, so that's going to cancel out, and the only unit we're left with is atoms. So to solve this, it's just 2.5 times 6.022 times 10 to the 23rd. So our answer is going to be 1.51 times 10 to the 24th atoms. Make sure you always put your units on your answers. And you may want to follow along with your calculator. Make sure you're able to come up with the same answer as I am. In this next example, we're starting with atoms of lithium, and we want to convert that to moles. So we're going to write down the number they gave us to start with. So we've got that many lithium atoms. And we want to convert that to moles. We want to cancel out lithium atoms and get to moles. We're going to take the same values from this conversion factor up here. We've just flipped it upside down to cancel out the units that we need to in this example. 1 mole is 6.022 times 10 to the 23rd. It's going to cancel out my lithium atoms. So I'm going to be dividing this time. We're going to multiply across the top and then divide as our last step. So 7.66 times 10 to the 25th times 1 divided by Avogadro's number should give us 127.2 moles of lithium. Molar mass, this is a very common conversion factor, and it's easy for us to get off the periodic table. Molar mass is just defined as the mass of 1 mole of atoms or molecules. Earlier we said that 1 oxygen atom has a mass of 16 atomic mass units. Well, if we had a mole of oxygen atoms, or 6.022 times 10 to the 23rd oxygen atoms, their collective mass would be 16 grams. It applies to molecules and formula units as well. if we have one water molecule, it's got a mass of 18 atomic mass units, 16 from the oxygen plus 1 each from the 2 hydrogens. If we have a mole of water molecules, it's going to have a mass of 18 grams. And it's used to convert between grams and moles. So here's some examples of that. In our first example, we want to convert 1.35 moles of carbon dioxide to grams. 1.35 moles of CO2. The units for molar mass are grams per mole, but we can also flip that around if we need to be moles over grams in the conversion factor. In this one, we want to cancel out moles, so it's going to go on the bottom. And we're going to put grams, the unit we're trying to get to, on top, grams of CO2. To find the numbers that go here, we're going to add up the masses of one carbon atom and 2 oxygen atoms on the periodic table. So that's 12 plus 16 plus 16. That's 44 grams for every 1 mole of carbon dioxide. Our moles are going to divide out, so we're going to be left with 1.35 times 44. So our answer is going to be 59.4 grams of CO2. In the second example, we're starting with grams, and we want to convert it to moles. We're going to start with 29.5 grams of CO2. And we're going to use the molar mass, same one that we used up here. We're still dealing with carbon dioxide, but we want to cancel out grams and get to moles. So grams is going to go on the bottom, and moles is going to go on the top. So 1 mole of carbon dioxide has a mass of 44 grams. So grams are going to divide out. We're going to do our calculation, it's 29.5 times 1 divided by 44, or just 29.5 divided by 44. So we should end up with 0.67 moles of CO2. We can string long chains of conversion factors together. That's what happens in most dimensional analysis problems. In this first one, how many water molecules are in 25 grams of water? We want to go from grams of water to number of molecules. It's going to take 2 steps for us to do that. We're going to start with our 25 grams of water. And we can't go directly from grams to number of molecules. We don't have a conversion factor for that. What we're going to have to do is go through moles. So we want to first convert into moles. So we want to get rid of grams of water and into moles. Well, 1 mole of water has a mass of 18 grams. We got that from the molar mass on the periodic table, 16 plus 1 plus 1. That's taken me to moles of water. Now, I want to go from moles of water to number of water molecules. We want to cancel out moles. We know that 1 mole of anything has 6.022 times 10 to the 23rd units in it. So I'll have 6.022 times 10 to the 23rd water molecules. So the units that cancel out are grams and moles of water. I'll be left with molecules of water as my answer. So to solve this, remember we multiply all the way across the top, multiply across the bottom, and divide as our last step. So to solve this, it's 25 times 6.022 times 10 to the 23rd divided by 18. Hopefully you should end up with 8.36 times 10 to the 23rd water molecules. Another example down here, we've got 9.99 times 10 to the 24th helium atoms, and we want to find the mass of those atoms. We can't go directly from number of atoms to mass. We have to go through moles first. So we got this many heliums. We need to convert it to moles. We want to get into moles. That's our unit we want to get to. We want to cancel out individual helium atoms. Well, 1 mole of anything has 6.022 times 10 to the 23rd atoms in it. This takes us from helium atoms to moles. Next, we want to go from moles of helium to grams of helium. We take the molar mass of helium from the periodic table. 1 mole of helium has a mass of 4 grams. Make sure our units cancel out. Helium atoms are going to go away. Moles of helium are going to go away. We're just going to be left with grams of helium. So to solve this one, 9.99 times 10 to the 24th times 4 divided by 6.022 times 10 to the 23rd. Hopefully you end up with something close to 66.36 grams of helium. Your question for this section, 5 grams of NaCl is equal to how many molecules? That shouldn't say molecules, that should say formula units.